Hi everybody, in this screencast we're talking about nonlinear systems of equations. What I want you to learn is how to solve a nonlinear system. So first of all, what I want to start off with is to visualize what we're talking about. Now we've done systems of equations in here before, but what we had before were linear systems where we were checking to see how lines were intersecting. But here's what we're going to do today. We have nonlinear systems. So for example, we want to be able to solve the system if it consists of a circle in a line, or an ellipse in a line, or a hyperbola in a circle, or an ellipse in a parabola. The different possibilities are endless. So that's visually what we're talking about. Now, how are we going to do this algebraically? What's the algebra of this? So first of all, this is what the systems are going to look like. For example, we have x squared plus y squared equals 16 and x plus y equals 3. Now, algebraically, we're trying to find that ordered pair or set of ordered pairs that's going to work in both of these equations. Same thing over here. So we're trying to find out where these are going to intersect. This is a circle, this is a line. We could have one point of intersection, we could have 2 points of intersection, we could have no points of intersection. This is going to be a hyperbola and a circle. We could have 1, 2, 3, or 4 points of intersection here. So this was a circle and a line. This was a hyperbola and a circle. Now, how are we going to solve these systems algebraically? Now, it all depends on what they look like. Now, over here with this system, I'm going to think about solving this using substitution. But because of the way this one is set up, where we have two x squared terms and two y squared terms, I feel like elimination might be the best method over here. Okay, so let's look at some examples and let's solve them algebraically. So here's our first example. X squared plus y squared equals 25 and y minus x equals 1. Because of the way this is set up, I don't have x squared terms and y squared terms in both of these equations. So I think substitution is going to be the best method. So what I'm going to do is I'm going to first solve this equation for y. So I added x to both sides. Now I'm going to substitute this this value for y, this substitution, I'm going to substitute it into the first equation. So I have x squared plus 1 plus x squared is equal to 25. When you square this, don't forget there's a middle term. So I get x squared plus 1 plus 2x plus x squared equals 25. And then I'm going to set this equal to 0 and combine like terms. So I have 2x squared plus 2x minus 24 equals 0. I'll divide out a 2 and then factor. And so I get x plus 4 times x minus 3. That gives me two solutions for x. X equals -4 and x equals 3. All right, I'm almost there. Now I know what the x values could be. So what I have to do now is solve for y. I'm going to solve for y when x is equal to -4 first. So I'll take that y minus x equals 1 equation and plug -4 into it. So y minus -4 equals 1, which means y is equal to -3. And so that means the ordered pair -4, -3 is one of my solutions. Now, what about when x is equal to 3? Once again, I'm going to plug that into y minus x equals 1. So that means y is equal to 4. So the other solution is when x is 3, y is 4. So the solutions are -4, -3, and 3, 4. Okay, let's look at another example. Now for this system, because of the way it's set up, I'm liking elimination. So I can just simply add these two equations together because the coefficients are opposite for the y terms. When I add those together, I get 2x squared equals 18. Divide both sides by 2. And x could be equal to plus or minus 3. Did you remember that there's a positive and a negative answer here? That is usually what students do wrong. So be careful. Remember, if the equation is x squared equals 9, there's two answers, plus or minus 3. Now, just like before, I'm going to solve for y. When x equals 3, I'll plug that into the first equation, which means y squared is equal to 5, which means y is equal to plus or minus the square root of 5. I had to pause the screencast and fix that. So it says y is equal to plus or minus the square root of 5. Now, that means the ordered pairs, I have 2 here. When x is 3, y is equal to negative square root of 5, and when x is 3, y is equal to positive square root of 5. Now let's see what happens when we plug in negative 3. Well, we end up with the same equation, y squared equals 5. And when we take the square root of both sides, we get y is equal to plus or minus the square root of 5, just like we did before. So these two solutions are negative 3, negative square root of 5, and negative 3, positive square root of 5. So in this example, we got 4 solutions. Okay, I would like to go through one last example with you. Now, in this one, which method do you think is best? I think substitution is best also. So what I'm going to do is in the first equation, I'm going to substitute x plus 5 for y squared. Now, I'll set that equal to 0. So x squared plus x minus 20 equals 0 and factor it. So I get two answers because x plus 5 times x minus 4 equals 0. That means x is negative 5 or x is 4. And so I have to solve for y. Now, when x is equal to negative 5, I really can choose either one of these equations. It doesn't matter. I'm going to choose the second one. So when I plug in negative 5 for x, I get y squared is equal to 0. So that means that y is equal to 0. So that's one solution here. When x is negative 5, y is 0. Now what happens when we plug in 4 for x? So I get y squared is equal to 4 plus 5, which means y squared equals 9, which means y is equal to positive or negative 3. So I have two solutions here, 4 negative 3 and 4 positive 3. So altogether, there are 3 solutions, negative 5, 0, 4 negative 3, and 4, 3. Okay, that's all there is to it. Good luck.